Okay, Joyce, whenever you want to start.
Okay, let's get started then. So hi everyone, and thanks for joining us this evening to talk all about science communication. We're so thrilled that this year Academia Week has decided to focus on the various issues relating to science communication. And there are tons of diverse and really wonderful speakers and workshops throughout the week, so we really encourage you to check those out as well. But for our presentation today, we're going to be focusing on sorry, one second. Marina, are you the host as well? Because I keep getting notifications of people popping up as waiting to admit. So I just want to make sure that I'm not the only one that can.
No, I'm host as well. So you can
Okay, sounds good. So for our workshop today, we're going to be focusing on giving a brief intro to why science communication is important and also defining what science communication is. And then we're going to also talk about what the state of science communication education at McGill is. Because while Marina and I are not experts in science communication, we are experts in being science students at McGill. So we'd like to share some of the problems that we've encountered over the past 4 years and talk about how our new student organization, the McGill Scientific Writing Initiative, is taking steps to fill in some of those knowledge gaps that we've noticed that many students have.
So first off, we just want to give a brief land acknowledgement. So the McGill Scientific Writing Initiative acknowledges that McGill University is on the traditional territory of the indigenous people called the Kanien'kehá:ka. The Kanien'kehá:ka are the keepers of the eastern door of the Haudenosaunee Confederacy. This island, known as Montreal, is known as the Geogaje in the language of the Kanien'kehá:ka, and historically has served as a meeting place for other indigenous nations as well. It's not enough just to acknowledge the keepers of this land and McGill's status as a settler colonial organization. Silence and inaction will only contribute to erasing the history, the culture, and the realities of Indigenous people across Canada. It's important to recognize that Indigenous communities are minorities in STEM, and as we discuss science communication in today's presentation, I'd like our audience to think about how to decolonize Cycon and make it more accessible for racialized scientists and individuals across Canada.
Okay, so let's start off with a brief introduction of who we are. So hi, my name is Joyce and I'm a fourth year psych student and I also minor in interdisciplinary life sciences. I'm interested in pursuing a career in the rehabilitation sciences and specifically, I'd like to see how as healthcare professionals we can better provide health education to our patients.
Hi, I'm Marina, and I'm a U3 physiology student here at McGill. And in the future, I hope to pursue biomedical engineering as a career, specifically involving medical devices and cellular therapies. And funny story, Joyce and I met on our very first day at McGill, and we've been friends ever since. And so the story about how the McGill Scientific Writing Initiative came to be kind of stems from that friendship. So back in May, right after finals had finished, Joyce and I were discussing how they went. So Joyce had asked me how virtual finals had gone. And as I reflected upon this, I was thinking about how this semester, last semester, all of the assessments really shifted from a highly dense multiple choice assessments to open response term papers. And that was a struggle for me because as a science student at McGill, we're all used to very long multiple choice exams. So I had thought about that and kind of texted Joyce some of my concerns. And she had said that she had felt the same way. So we kind of investigated the question of what sort of resources are out there for McGill science students to help them better communicate via writing or oral presentation their scientific discoveries. And that's how the McGill Scientific Writing Initiative was born. In short, the McGill Scientific Writing Initiative, which we call MSWI, is a student-run organization dedicated to helping students navigate science communication in academia and beyond as well. And our main focuses are written resources, live workshops, and a yearly case competition. So we'll explain more about what MSWI has to offer in more detail later on, but first let's discuss more about science communication and its importance in society.
All right, so what is science communication and what are the different forms that it can take on? So scientific communication involves informing, education, educating and raising awareness about science-related topics. And the goal is to increase the sense of wonder about scientific discoveries and findings, and engagement in how science affects us in various aspects of life. And the tricky part is that different audiences have different educational backgrounds and come from different cultural backgrounds. So we really have to tailor our communication to our audience. Okay, so communication often seems like a very simple concept because it's something that we've engaged in since birth, but it's actually quite complex because there are so many different moving parts, which means that there are many areas in which communication can go wrong. So this diagram kind of breaks down the different components of communication. So on the top left-hand corner, we have the source, which as a scientist would be you, the communicator, and then so you encode a message, which is then transmitted through some kind of medium, whether that's through a speech or written text, or if you're using an art piece. And this message is then decoded by the receiver, who also will send feedback. And there's also the inclusion of noise in this model, which we'll go into more detail later on. So it's not enough to just be good at one of these steps. So each of these steps are points of intervention where we have to focus on improving in order to improve science communication on a more holistic level. So first, let's take a look at how we can more effectively encode or deliver our message. So how we tailor our communication to our audience depends on two questions. So first is, who is your audience? And second is, what is your main goal? So some factors to consider about your audience would be like their age, their educational level, why they're interested in your topic, if they're even interested in your topic, and what their priorities are. And looking at what your goal is, you have to figure out if you're trying to educate, if you're trying to inform, if you're trying to convince someone or change their mind. The answers to these two questions will all affect how you encode your message. So what format you use, how much technical language you use, and even what kind of tone you take on. So now we've talked about the encoding part, we can also talk about the decoding aspect. And this is something that we often don't really consider as scientists, that it's equally important that people are able to effectively understand your scientific message. And we can do this by promoting science literacy at every age. So for children, this means incorporating science education into their play and into their daily exploration of the world, so that early on, they develop this strong sense of wonder about how the world works. For adults, this means encouraging science education beyond high school. So I grew up in Toronto, and in Ontario, science education isn't mandatory beyond 10th grade. Which means that a lot of people who don't go on to study STEM in higher education or pursue a career in STEM are interpreting science with knowledge that they gained 10, 20, 30, 40 years ago, which is problematic because I don't know about you guys, but I certainly don't remember much from what I learned in 10th grade. And when we think about promoting science literacy, it's also important that we not only focus on teaching people factual knowledge about science, but also conceptual knowledge, because this is what they will transfer and use in various contexts. Equally important is educating people about how to identify reliable sources, especially since misinformation and pseudoscience is such an important issue these days. And there's so many people sharing information online that is inaccurate because they try to pass it as their scientists, but they don't really have the credentials or expertise to back up their claims. Okay, so now we've talked about how to encode a message and how to decode a message. And so let's talk about noise. So noise is not necessarily a bad thing. And it's definitely not something we can completely get rid of, but it is something that we have to consider because it's what makes science communication really complex. And it's what makes it really hard to communicate a message to any kind of audience. So two factors that I'd like to talk about today are cross-cultural perspectives and also pre-existing knowledge. So taking a look at culture first, Our cultural background affects how we interact with every aspect of life, and that includes how we understand scientific topics. And this results in different people having fundamentally different views on scientific topics that seem universal. And none of these views are more correct or more valid than the others. They're just different perspectives. So one example is a study that looked at the idea of ecosystems and how culture affects how we perceive ecosystems. So what they found is that individuals from an indigenous background tend to perceive humans and our habitats as being fundamental components of the ecosystem, whereas non-indigenous and European communities will view ecosystems as kind of everything other than humans. So they don't really think of people or urban communities as being part of an ecosystem. And this doesn't necessarily mean that if we talk about ecosystems in one way, the other group just won't understand it at all. But it is important to consider that if we're consistently gearing science communication towards, the majority population or a certain group, we end up excluding and failing to engage an entire demographic. And this ends up translating to underrepresented minority groups pursuing STEM careers at a much lower rate. And even those who do go on to pursue careers in STEM or study STEM are less likely to complete their degree and stay in STEM. So the other source of noise that I'd like to consider is pre-existing knowledge. So we all come into classrooms and conversations with 20 years of experience in the world. So it's important to ask, what does this person already know? And importantly, what are some false beliefs and misinterpretations that they might have about a scientific topic? Because in some cases, if you're trying to educate someone about a topic and maybe change their mind, it's hard to do that just by adding more facts, because what you end up building is just an incoherent model where they have a lot of contradictory information. And sometimes we have to actively undo information before we can educate and teach more knowledge. Okay, so we've talked about encoding a message, we've talked about decoding, and we also talked about noise. So evidently, there are a lot of factors that we have to consider when we're communicating science. And this is kind of overwhelming, and we can't really just have a checklist where we tick off all the boxes that we've considered. So perhaps the easiest way to ensure that we're constantly thinking about who our audience is and tailoring our communication to be suitable for this audience is to ask questions. And this brings us to the feedback stage. So we sometimes think about feedback as being the last step in the model. So you produce a product and then someone tells you if you did a good job or not. But we can use feedback as the first step so that we anticipate potential sources of miscommunication and misinterpretation so that you get it right the first time. And this can be as simple as asking questions like, what do you know about the topic? What are you most interested in? What would you like to learn from me? This not only allows us to better understand our audience, but it also engages our audience. And as scientists, we sometimes fall into the trap of being so passionate and interested in a topic that we kind of just ramble and talk about everything. But for the person you're talking to, this can be incredibly overwhelming and sometimes just feels like a person is just shouting scientific facts at you. So encouraging our audience to more actively participate in the conversation furthers the idea that science can be accessible and that you don't have to be a scientist or an expert to participate in a conversation about science, to care about science, or to have a voice in scientific topics.
Right. So Joyce just talked about how science communication works. And now let's ask the question, why is improving science communication important? What is the impact of better STEM communication in society as a whole? So, like Joyce talked about before, the audience of science communication is diverse and includes policymakers, administrators, patients, industry professionals, and the general public. It's becoming increasingly important to recognize science research and discovery cannot operate in a vacuum. In other words, researchers must successfully convey their discoveries to parties outside of STEM to make a change. We have two examples here. Let's zero in on the first one, which is the importance of effective science communication in environmental studies. So in this scenario, let's say that you're a researcher who just conducted significant research findings on the impact of plastic waste on fish in the St. Lawrence River, right outside Montreal. Just making that discovery is not enough. Now, you must communicate this finding to government officials, media, and policymakers to successfully implement a strategy to protect the river wildlife. In other words, if you don't communicate the findings, no change will take place. Another example, which is a quite relevant topic in this day and age, is in health and medical care. Researchers studying the transmission of COVID-19 must translate their findings to officials, media, and public in order to make new guidelines and educate the public to keep them safe. Overall, science communication is necessary to translate findings from STEM into actionable change in society. So what's going wrong in this process, and how does MSWI solve this problem? Additionally, what's our impact on educational and societal levels? So Joyce and I sat down and thought about a few different problems within the educational and societal systems today. The first issue that we thought of was that Cycon is expansive and extensive in its network of resources, which can be overwhelming. If you think about Googling a scientific term, how many thousands of results pop up, and how do we know which are reliable and accurate? Another issue is that Cycon produces few opportunities for students to develop their Cycon skills with low stakes. So in my experience at McGill, I have been mostly in classes with a large number of students who have had multiple choice exams. And so for the first 3 years of my degree, I really never had a chance to effectively practice my written or oral presentation skills. Additionally, right now, communicating science is mostly focused on doing so within academic communities, aka other researchers and scientists. So we must shift this focus to other demographics, including media, general public, policymakers, like we talked about before, to make this information available and make action on them. The fourth thing we came up with in terms of issues relating to Cycon were that oral communication skills are ignored. We spend many hours writing papers when you're an upper-year student, writing lab reports, but how often do we present these? How often do we get practice to present these to large audiences and to improve upon your oral communication skills? And lastly, at a large school such as McGill, detailed and individual feedback is so rare. So we're hoping to use MSWI as a platform to address some of these problems.
So as Marina explained, there are several problems in how Cycon education is being addressed nowadays. So this is where MSWI steps in to kind of fill in the gaps that universities haven't really done so already. So as Marina kind of explained in the beginning, our goal is to provide future scientists and future healthcare providers or industry professionals with the tools necessary to successfully convey their scientific knowledge to diverse audiences, whatever their field is. And our goal as a student organization is to fill in the gaps where higher education is not teaching students enough. And we work a lot faster than large institutions like McGill, which is why we're able to kind of establish ourselves as a broad resource before these changes can be made in higher education. So we have a QR code here that you can scan to reach our website, or you can type in mcgill-mswi.com to reach our website. And on here, we have tons of resources. We have an event page. We also have our blog where we post lots of cool hot topics in science. And Marina will kind of go over that later on.
So our first class of resources that the McGill Scientific Writing Initiative provides are written resources about science communication, STEM, and student life in general. Our largest resource is an ebook about 30 pages long called A McGill Guide to Scientific Writing. And this book contains chapters on the different types of scientific material, lab reports, structures of research articles, and even vocabulary. Our other general resources include a guide to clinical abbreviations for nursing and pre-med students, as well as standardized testing written resources for the GRE and MCAT. We also have McGill specific resources, and one of them is a guide to lab reports at McGill specifically. Our team worked with professors directly over the summer from chemistry, biology, immunology, and more to find out what type of mistakes students make and how to succeed in their classes. So if you have any labs this semester and next semester, feel free to download the lab report resource to find out what you can improve on in your lab report skills. And additionally, we have a list of Cycon classes at McGill, which we highly recommend that you look into so you can help initiate more effective science communication. And feel free to download any or all of these written resources on our website.
We also offer monthly workshops, which we hope give students a very low stakes opportunity to practice their science communication skills. So for these workshops, we usually invite an expert in the field, so typically a grad student or a professor from McGill, to give a 30-minute talk about their topic, and then the other 30 minutes are reserved for an interactive component and a Q&A session. So our goal is that we give students an opportunity to practice so that the first time that they're writing a research paper or giving a presentation isn't for a class assignment that's worth 50, 60, 70% of their grade, because that is super overwhelming. So some of the workshops that we've offered over the past few months include reading a research article. We had a panel discussion with undergraduates who have published. We had one that was all about science communication. So Dr. Diane DeChef shared some tips about using literary devices to really capture your audience's attention. And we also had one about writing a personal statement.
In terms of more traditional forms of media, we also send out monthly newsletters and biweekly blog posts. And our topics range from equity in STEM, like the screenshot you see on the slide, as well as student tips and tricks and promotion of upcoming events. And a really cool thing that we do with our blog posts are we feature undergrad students who have recently been published in journals, because we believe that undergrad accomplishments in Cycon should be celebrated as well. So feel free to check out our page and contact us if you want to be featured.
The final big project that we've been working on this year is putting together the Cycon case competition. And the goal for this is, once again, to provide students with a low stakes opportunity to practice their skills and also to learn about some formats of science communication that they might not be too familiar with or they haven't really encountered in class. So the tasks that we've given our participants include writing a news report, and the audience for this is a general adult population, a children's book, which is geared towards third graders, and also a literature review. And the audience for that is an academic audience. So we're super thrilled that this year we have 22 teams representing 6 faculties and 28 majors, which is a great representation of how you don't have to be a science student to care about science or want to learn about science. And what we offer our case comp participants is a plethora of workshops. We also have mentorship with grad students and also a networking event with our professor judges. And we also are hosting a symposium at the end of the competition so that students can practice their oral communication skills. And for our winning teams, we have prize money and opportunity to publish in a peer-reviewed journal. So this is a very big project, and we have a bunch of sponsors and partners who are helping us make this happen. So the Office of Science Education, Sustainability Projects Fund, the McGill Alumni Association, and also MSurge and the McGill Tribune. So thank you very much to our sponsors and partners.
And on top of all the things that we've been working on as an organization, we also have some goals in terms of the future, and they all kind of fall under one umbrella, which is promoting Cycon across North America. And we have a few different pathways in which we want to do this. So the first is we want to include more CEGEP students getting involved in Cycon and being more aware of this issue. So the first steps we've taken towards this are recruiting a CEGEP representative to our team who will be helping us host joint events and getting CEGEP students more involved in our community. And we're also hoping to expand our initiative Canada-wide. We've had students from various universities, including Western, contact us about opening up their own regional branches at their university, which is really exciting because it shows us that this issue that we're trying to tackle isn't just localized at McGill, but it's an issue across all of higher education. And in the future years, we'd like to expand our case competition to include more students, including potentially high school, CEGEP, and university students from other universities across Canada. And lastly, we'd like to collaborate with other organizations dedicated to Cycon, whether they be on the educational or professional level. If there's one thing that Joyce and I would like you to leave this workshop with, it's that improving science communication is essential for a society as a whole. We hope to enable the next generation of scientists to create an impact with their work. In the future, we hope that science communication becomes integrated into our education, just like any lab skills or memorizing the citric acid cycle is. MSWI, the McGill Scientific Writing Initiative, hopes to bridge this gap at McGill and hopefully in the future to the rest of Canada as well.
So as we wrap up our presentation, we'd like to also acknowledge our entire MSW team who, so we have 10 students who work incredibly hard to put together all these resources and workshops for students. And they do this on top of being full-time students and having part-time jobs and contributing to their communities in various ways. So we're very lucky to have a hardworking and passionate team. And since most of us are graduating, we're also recruiting soon for our 2021-2022 exec team. So if you're a student and think that you might want to join our initiative, we have a link that we'll put in the chat where you can fill out an interest form and be notified when we start recruitment.
Yeah, I just sent it in the chat, Joyce.
Okay.
If you just scroll to the bottom of that page, you can fill in your name. And with that, we'd like to say thank you for watching our presentation, and we'd like to open it up to the floor for any questions you may have. You can like unmute yourself, or you can, thank you, Sabrina, or you could write in the chat.
Do we want to maybe stop recording?
Oh yes,
that makes people feel more comfortable asking questions.